Hi, Assalamualaikum warahmatullahi wabarakatuh. My name is Elia Hani Zulaikha. Today, my friend and I will represent about Lab 1, which is Transfer Function and System Response.
First, we derive Laplace transform equations from the diagram. Then, we represent the equation in metric form. After that, we find the determinant value of A and sign the value to the metric form. The value of the determinant that we get in A was calculated by using AD minus BC. For this, this is the determinant value that we get for A. Next, we find the value of A1. For this part, we replace 0 and F on the first column. Then, we find the determinant value of A1 and sign the value to the matrix. The value of the determinant that we get in A1 was calculated by using AD minus BC. This is the determinant value that we get for A1. As for A2, we replace 0 and F in the second column, and this is the value that we get for A2. The value of transfer function of x1 was determined by dividing the determinants of a1 and a, and the value of the transfer function of x2 was determined by dividing the determinants of a2 and a. Lastly, this is the value of transfer function for G1S, while this is the last answer for G2S. Thank you.
Assalamualaikum, my name is IZZATI. Now I will explain to you the MATLAB for part A. First, we declare the value for M1, M2, K1, K2, FV1, FV2 and FV3. After that, we use the command sims to declare S and F parameter. Then, we write the matrix for A, which is this. This is the Laplace transform equation that we obtain from the diagram that we represent in the matrix form. Okay, for A1, we replace the first column with 0 and F, while the second column is same as the previous. For A2, we replace the second column with 0 and F, while the first column is same as A. Then we find the equation for x1. So we use the command x1 is equal to determinant A1 divided by determinant A. Then we get the equation for x1 is equal to this. Then for x2 is equal to determinant A2 divided by determinant A. And then we get the equation. Then we get the equation x2 is equal to this. For figure 1, first we declare the numerator and the denominator. After that, we generate the transfer function for x1. We use the command tf bracket numerator comma denominator. Then we get the transfer function for x1 is equal to s plus 1 over s power of 4 plus s plus 5 s power of 3 plus 8 s power of 2 plus 5s and plus 1. Then we use command step sys x1 f to plot the output response of x1. Then we get the output response for x1 is like this. Okay, for the figure 2, we repeat the same process. First, we declare the numerator and denominator, and then we find the transfer function by using command tf bracket numerator comma denominator. Then we get the transfer function for x2 s power of 2 plus 3s plus 2 over s power of 4 plus 5s power of 3 plus 8s power of 2 plus 5s plus 1. Then we plot the output response by using step command and we get the output response like this. The shape is same as x1. Then for the figure 3, plot the both output response in the same figure by using command step bracket sys x1f, sys x2f. Then we get two output response on the same figure. As you can see, the red is the x2 and the blue is x1. So x2 output response has the higher value than the x1, and the steady state of x2 is greater than x1.
Assalamualaikum, my name is HAMIZAHTUN. For the calculation in part B, at first, we use mesh analysis to extract the equation for first loop and the second loop. The equation from mesh 1 get from loop 1, which is I1, and the equation from mesh 2 is from loop 2, which is I2. After that, from this equation, we put the equation into the metric form. A is A. From this form, we determine form A to obtain a new equation. Then we use the equation from mesh 2 to put into the metric form, that is A2, to get the determinant equation for A2. The equation of mesh 2 is used because the desired voltage value is the voltage value on the inductor, and only in mesh 2 have an inductor equation. After that, to obtain the value of I2 is by the equation of determinant A2 divided by the equation of determinant A. From the equation, I2 will be used to obtain the equation of VL, where VL equal to I2 multiplied with LS. Then subtract VS so that it become the equation for VL divided by VS. After that, replace the variable for R, C and L to the given value, then simplify the equation. And this is the final equation that we got.
Hi, my name is IZZATI, and now I will explain to you the MATLAB for part B. First, we declare the value of R1, C1, R2, C2, R3 and L. After that, we use command sims to declare S and B. Then we write the matrix for A. This is the equation that we get from the mesh analysis that we write in the matrix form. For A2, we replace the second column with V and 0. And the first column is same as the previous. Then we find the transfer function for I2. I2 is equal to determinant A2 divide determinant A. This is the equation that we get for I2. Then we calculate VL. VL is equal to I2 times S. So this is the equation that we get for output VL. After that, we declare the numerator and denominator. Then we generate the transfer function for equation VL by using command TF numerator, denominator. Then this is the transfer function that we get for VL. Then we use command step bracket SYS VL to plot the output response of the transfer function. This is the output response that we get for transfer function VL. So as you can see, the output response is go down and then reach its steady state response.